What's up, Node.js developers? Welcome back to a new live tutorial, and in this video we're gonna learn how we can deploy a custom Node.js API to production using AWS EC2 instances for our servers and also AWS RDS for our database, for a Postgres database. So that's what we're gonna do in this video, and I want to mention that this tutorial is going to be useful for two types of viewers. So if you are the first one, if you're looking for how you can deploy a REST API, if you're working on a custom REST API and you're at a point where you have to deploy it to production, I can imagine that it can be quite confusing to do so, and you search for a solution for that. Most probably you found this video through search, so this is a great tutorial to follow along, but I'm gonna use a very specific project to show how to do that, and we're gonna do everything by example. The second type of people who would enjoy this tutorial are the ones who are following along our Twitter clone series, where we're building a full stack mobile applications using React Native, Node.js, and now we are deploying this to production. So if you are interested in learning full stack mobile development, then check out the previous episodes. We have 3 episodes that led to this one, where we build in one of them the React Native part, the mobile application, in the other part the backend using Node.js. We connected them together, but up until now everything is working locally, and the goal would be to deploy our backend to the cloud, to production, to make sure that it is available to our end users at any point in time when they want to access and use our application. So nonetheless, all the code that we're going to use in this project is available on GitHub, and you can find the link in the description below. And I'm going to provide everything that you will need, and you can follow along this tutorial even if you just got here. So yeah, with that being said, the plan for today is real quick, is going to be, first of all, we're gonna set up a EC2 instance that is going to be our server in cloud. We're gonna see how we can connect from our local machine to the EC2 instance in order to set up the Node.js environment to be ready to run our Node.js API. Then we're gonna set up our API in the cloud to be able to be accessed by anywhere. And then we're gonna get into the database. For that, we're gonna set up an AWS RDS database for Postgres, and we're gonna connect our application with that database to connect with that one. So, and then I'm also gonna show how we can clean up everything, and all of this tutorial is going to be part of the AWS free tier. So we're gonna use only the services that are part of the AWS free tier, so you're not gonna get charged anything for running this backend instance on AWS. Yeah, I think that's the plan. If you're ready, I am ready. Let's get started. And while I'm running the intro, please introduce yourself in the live chat. Hello, guys. All right, so hello everyone in the live chat. Today we're starting a bit earlier because I have a conference talk today, so I have to manage to prepare and do that as well at our usual time, but I hope you will, this video will be published on the channel, so you will be able to access it. Yeah, let me know where are you joining us from, and while you're doing that, I'm gonna go ahead and get started with our application. So first of all, the code, the backend, the Node.js backend that we're gonna use to deploy today, you can find on GitHub. You can also, the links are in the description below. And this is the Twitter backend. So let's go ahead and clone this repository locally, because we're gonna have to do some changes there as well. What you can do is probably you can fork it on your account to be able to push changes to that repository in your account. I have it here. So after you clone it, let me probably do it like this. Zoom in a bit. Clear. After you clone the repository, go ahead and install the dependencies using npm i. Okay, that installed our dependencies. And what do we have to do here? Well, first of all, we can go ahead and make sure that everything is working by running npm run dev, because we have a development script, and that would execute with ts node the index.ts, and we see that our server is running locally at 3000. Now, what we can do is we can open localhost at 3000, and that should be a simple hello world, because that's what we have for the index route of our API. However, if you look here in the routes, we also have authentication routes that are under the /auth, and also tweet and user routes. I'm not going to get into a lot of details because it's out of the scope of this tutorial. What we are interested in is to deploy this, but I'm going to show you for later on to test if everything is okay. We're going to need some kind of HTTP client. Basically, we're going to need to be able to send some requests to our API. For that, I'm using Thunder client. You can use Postman, or you can even use curl to send these API requests. And for example, if I'm going to send this auth login with my email to the localhost, if I do that, we see processing status 200, everything was sent. And if I look in the console, we see that I also received an email with my one-time password. So far, everything is working in development mode. Let's go ahead and prepare some of the things that we will need in order to run this application in production. First of all, we will need to create the tsconfig file that will specify how do we want to build this application. Because in development, we are using TS Node, but for production, we would have to build this application using TypeScript. And for that, we're going to need that tsconfig file. So I'm going to start the server, and let's go ahead and do tsc, or let's work with npx tsc and then -- init to initialize our basically TypeScript file, tsconfig file. That created a very blank and default TypeScript config. I'm not gonna change a lot of configuration of TypeScript here, but what I want to change is, if I scroll down, there is this outdir. Where is it? You can also search for it, this one, outdir, which specifies where do we want to write the output of the build project. So let's go ahead and write here in the build directory. So the outdir will be our build directory. Now we are ready to create our first build with TypeScript. And for that, I will go ahead and let's add a new script in our package.json to help us manage everything easier. And let's call this script build. And what we're going to do is let's do npm run or just tsc to do that build. Now, if I'm going to open the terminal and do npm run build, what this will do, it will create, build our TypeScript project, and we see a new folder build in our root of our project. Okay, perfect. Now, what we would be able to do is, at this moment, we can simply run this index.js using notJS without having to have TS node, because the build part of the build is already the JavaScript side of our application. So what we can do is we can do node and the file build index.js. And we see server is running at localhost. I'm going to stop this one because I don't need it at the moment. And I want to add a new script here that will help us start this production server of our project, of our Node.js API. So for the start, I want to make sure that every time we start this production version, we are actually building it first. So let's do npm run build. And only then, only after building it, we're going to run this using Node. We're going to run build index.js. And now what we can do is simply do npm run start, and that will first go ahead and make sure it rebuilds the project to have a latest version of our source code. And after that, we'll run Node on our build project and run our server from there. Okay, perfect. I think that's what we need at this moment. So I'm going to stop the server and go ahead and do a git add, git commit, prepare for production. Let's do it like this. And let's push the changes to our git push origin main to push the changes to our Git repository. So now if I'm going to go to the Git repository and refresh, we should see the tsconfig and also the package.json. Actually, I'm going to do one more thing. As you can see, our .env file is in gitignore, so on Git we do not see this .env. To simplify our process of creating a env file on our backend, what we usually do is we create an example env that will specify what variables do we want to provide there. So what we can do is we can copy paste this .env file and let's call it env.example. And in this env example, make sure to delete everything that is secret basically, and only leave the variables that we need there. This way, now if I'm gonna do git add, git commit, add example env, git push origin main. This way, anyone who will want to run our project, they will have this .env example and they will understand like what environment variables they have to provide in order for this application to run properly. That is going to help us in a bit. Yeah, I think we are done with preparing our application to be run in production. And the next step, let me see what are people saying. Hello, Muhammad, Vladimir, hello, Tahir, Alexandru, salutare. Hello from Telecentro, Radu, hello. All right, guys, so the next step is we're gonna use AWS EC2 to create a server in the cloud where we will be able to run this Node.js application, and this way our API is going to be always up, is going to be accessible by anyone at any point, and it's no longer going to run on our machine, so we can safely restart our computer. So that's a requirement to basically go to production. And for that, as I said, we're going to use AWS EC2. For that, you will need an AWS account. So if you then don't have one, you can create one for free at aws.com. It's free to create an account. However, you will have to put your credit card details, but all the services that we're going to use today will be covered by the free tier, which for 1 year provides some limited use of these services for free in order to learn and experiment with AWS. So after you have done that, we can go ahead and open the AWS console. So here in the AWS console, let's go ahead and start by searching EC2, virtual servers in the cloud. So basically this is going to create a Linux server where we can run anything that you would be able to run on a Linux server. So on this page, what we want to do is let's go ahead and press on the launch instance to launch a new instance. Here, go ahead and name your server, for example, Twitter API. In the next tab for the application and the operational system image, I'm going to use the Amazon Linux that is provided by AWS. It's a Linux distribution, but it's also set up with AWS CLI. So yeah, let's go ahead and use this one. Optionally, you could also use the Ubuntu version. But in that case, like if you would need like AWS CLI, you'd have to install and set up it manually. So let's go with Amazon Linux. For the image, I'm gonna use the default one, which is also free tier eligible. Make sure you see this one here. Let's leave everything else by default. For the instance type, the instance types specifies how powerful should the physical machine be where our server is running. So for free tier, we have this T2 micro, and that's it. Like if I scroll down, I don't see any other free tier. So this is an important step. Leave it at, where is it? Leave it at T2 micro or any other free tier eligible instance type. This one provides one virtual CPU and 1 GB of RAM memory, but that's more than enough for learning how to deploy this. Later on, if you go to production and you need more, you're going to be able to select and run the server on something more powerful from this list, but that will increase also the cost, and you actually see the cost here, which is indicated per hour. So for now, T2 micro is fine for us because it's also free tier. And let's go ahead and move to the key pair. Key pair is a way that will allow us to connect to our instance. So we're going to need this to securely connect using SSH to our Linux server. So what we have to do is, let's go ahead and press create a new key pair here. For the key pair name, let's do Twitter API key, Twitter API key, leave RSA, and I'm going to use a .pem extension. If you're working on Windows, if I'm not mistaken, you'd have to use the .ppk for the putty, I don't know. So let's leave .pem and create the key pair. That will automatically download this key pair locally. And remember where you downloaded it, and probably it's a good idea at this moment to move it to a safer place, not in your downloads folder, because in downloads you most probably will lose it. So move this key to a safer place, because we will need it. We will always need this key whenever we will want to connect to our server. Moving on to the next part, network settings. Let's create a security group. And for the rules for this security group, the security group is basically the firewall of our server. Meaning, with security groups, we specify who is allowed to access our server and through which ports. For example, we will want to connect through SSH to the server to be able to set up and install and configure everything. So for that, we're going to need to allow SSH traffic, and you can leave it from anywhere, but that's not very secure. So what I would recommend you to do, to select here my IP address to only allow connections from your IP address. Next one, I will also select the allow HTTPS and HTTP, because the server that we're going to build is actually, it should be accessible through HTTP traffic. Like basically anyone in the world can send traffic to the 80 and 442, I think, port to be able to access the server. So let's select those and let's move to the next step. The next step is configure storage. I'm going to leave it by default. And let's leave number of instances 1 to only launch one of them. And I think that's everything. We can look at the review command. I'm not sure like if you need to go there, but double check everything that you created was similar to what I did. And let's go ahead and press launch instance to launch our first EC2 instance. Vladimir is asking, does that per hour cost is constantly or just per hour while there are activities on the server? That's a very good question. So the EC2 is priced per hour of the time that your server is running. It doesn't matter if it receives traffic or not. If it is running, basically if it is available, I'm going to show you how to check that. That means that you are being charged. I mean, if you are not under the free tier. So this is the difference between serverless and serverful, I would say, computing, where the serverless, for example, if you are using a AWS Lambda, in that scenario, you're only charged when there is basically activity. So if you have zero activity, you're gonna not get charged anything. While with a serverful, there basically is a computer, a server running for you always in the cloud. So you would have to pay for that. And that server is running because it always is waiting for people to access it. Otherwise, hopefully that answered your question. Now, going back to our instances here, we see that we have successfully initiated and launched the instance. Okay, the next step, we can go from here, but yeah, let me actually go to simply our EC2 dashboard. And from here, we can go at under the instances, and we see here our Twitter API. We see that the instance state is running, so that means that the server is running and we are being charged. And what we want to do here, maybe I'm gonna zoom out a bit because there is so much information here. Let's actually press on this instance ID to open the detailed view, only to focus on this one. And what we can do here is let's go ahead and press on the connect. And this will show us some examples of how we can connect to this instance. I'm gonna go to the SSH client here, and let's follow the instructions to connect to this instance. What I'm gonna need is I'm gonna need to open a terminal. So let's open a terminal. I'm gonna zoom in a bit. Let me maybe put it this way. Let's try this way. So, as we can see, we need to locate our private key. And this is the key that we download. It automatically was downloaded when we created the private key and when I mentioned that you need to put it into a safe location. So make sure to find the location of that file. For example, for me, that's inside the downloads. I'm gonna leave it there just because I'm gonna delete it afterwards, but Twitter API key. So yeah, this one is in downloads Twitter API key. For you, make sure that you are using the location where you moved this API key. The next step is we need to change the permission of this key, otherwise it's not going to allow us to use it. So let's go ahead and use chmod 400 and let's do downloads/Twitter API key.pem. Oh my god, no. What did I do? So let's change the permission of this key to 400. And now we are ready to use SSH to connect to our server. So with SSH, we need to provide this key using the -i property. Then let's go to downloads, Twitter API key, basically specify the path to your private key. And after that, we are ready to use the connection string that you can see here. So I'm gonna copy it from here. You make sure to copy it from your instance. But the way it is composed is EC2 user. This is the username to which we want to connect. Then we have the @sign, and after that is basically the DNS name of our instance. This DNS name is also available if we go to our instance page and we see here public IPv4 DNS. So you can find it here as well, but make sure to use EC2-user @ before that. Now let's press enter. And if this is the first time we're connecting to that, we need to confirm the fingerprint. So let's press yes. And what we see is Amazon Linux 2023, which means that we have successfully connected to our Linux machine, which is running in cloud through SSH. So that means that so far we have successfully created our EC2 instance, and we connected from our local machine to this EC2 instance from the cloud. And that will allow us to configure this machine to run our server, and later on actually run our server there. If you have any questions, feel free to ask them right now. Vladimir asked a follow-up question to the previous one related to serverless with Lambda and with the traditional with servers with EC2. And he's asking if we can create a Lambda and based on context execute different actions. Yeah, that's possible. That's the serverless model. It would be like completely different. Like it's not just deploying this to Lambda function. You'd have to basically adjust it differently and create it differently. But that's also possible. But if you have like a REST API, like going through EC2, like probably is the easiest way. And something to mention, like this free tier instance is going to be enough to run your backend application for quite a while until you get like some good traction. So don't worry that it's very small. It has only one CPU and 1 GB of RAM. It's gonna be enough for running the application for quite a while. Like until you get, I don't know, thousands of users, you're not gonna have any problems. So you can use the free tier, run until you get some problems, until you get like into the limitations, until it starts not handling the load, and then like you can think about increasing that or even running multiple EC2 instances and distributing the load with a load balancer between multiple instances. That's also possible. But that would be like a next step. Okay, guys, so now being connected to our AWS EC2 instance, our server running in the cloud, the next step would be to go ahead and set up this Linux system to be ready to run Node.js application. For that, what we need is to install Node.js, because at the moment this is a blank Linux system, and if we look node/v, there is no node command. Like we need to prepare it for specifically our use case. So in this step, we're gonna, what happened here? It didn't like the clear command. Doesn't matter, clear. Okay. So in this step, what we are going to do is we're going to install and configure Node.js on our EC2 instance from which we are connected using SSH. For that, we are going to use a node manager, which is called NVM, and this is the easiest way to install and keep track of node versions. So if you search on Google NVM and open the GitHub repository of NVM, in the documentation here, you'll find the installation guide. What we need is we're going to use curl to install NVM. So let's copy this command from here, paste it in our terminal that is connected to our EC2. This is very important because we're not executing this locally. We're executing on the cloud, on the EC2 instance. So let's press enter. And we see that it downloaded it, it appended, like it did everything that it has to do. Now, if we would run NVM, we still have command not found. So what we have to do is to restart, basically close this terminal and connect again for the changes to take to be taken into the consideration. Or we can simply do source, and we're gonna use the bash dot/bash rc. Is it rc? Or how is it? Oh, it's the squiggly line, which means from our home directory, go to that .bash rc, and using source basically load that again. And now after executing that, if I run nvm -v, we see that the version of nvm is 0.39 or something else for you. But that means that NVM now is installed and we can use it to install and configure Node.js. So to install a version of Node.js using NVM, we can simply do nvm install. And here what we can do is we can provide a flag --LTS to use the long-term support version of Node.js. If you open Node.js website, currently, at this moment of recording this video, the LTS version is 18.6. This is the long-term support, and this is recommended to run in production. If you want to use the latest updates and latest features of Node.js, you can use the current version, the 20, but that's a bit risky because, it's not yet the LTS version. So using that nvm install LTS, installed our Node.js, and what we can do is we can verify that Node.js is installed. Let me try to do a clear here. And let's do node/v to check the version of Node.js, and we see version 18, and we can do the same with npm/v, and here we see 9.5.1. I'm gonna make sure that everything is installed and configure always basically in the path. You don't have to do the next step, but I'm gonna close this terminal and I'm gonna open it again just to make sure that our Node.js is installed, everything is working fine even after we close and open the terminal. So what I'm gonna do here is this currently is a terminal inside my system. So what I have to do is to first SSH back into my EC2 instance. And after I do that, and after I see this at the beginning EC2 user, now I can execute commands on my server. For example, node -v, it's Node.js version 18, which means that we are ready to run and use Node.js on this server. The way we are going to get, the next step is to get our application, our Node.js application, to this server. How we can do that? The easiest way would be to use Git and basically pull the changes from our repository to our server using Git, the same way as we took clone the repository to our local machine, we can do the same to our server. So to do that, first of all, we need to install Git. So let's go ahead and run sudo yum update -y. We're gonna use yum for the package manager to install Git. And after that, we're gonna do sudo yum install Git and also -y to say yes to all the defaults. That will install Git. Like, I'm gonna scroll up to show you the command once again. Sudo yum install Git -y. And after that, I can do clear. And what we have is, if I do git -v to check the version, we see that Git version 2.4, which means that we installed Git on this system. Perfect. Now with Git, it would be as simple as cloning our backend repository. So for that, go ahead and open it on your GitHub account, or if you don't have it on your GitHub account, you can go ahead, open notjust..Dev/Twitter backend. You can use ours as well. I think it's gonna work fine. And from here, it's too zoomed in. What I can do is I can get the HTTP clone URL from code here. Let's copy it from here. And on our server, I can do git clone and paste in the URL. Now we see that it's cloning in Twitter backend. And if I do ls to list all the files in the current directory, we see that we have a directory Twitter backend. Perfect. The next step is to go ahead and install all the npm dependencies. So for that, let's cd first into the Twitter backend, basically to move into that directory. And now if I do ls, we see all the folders and packages from our project. That's perfect, but we don't have node modules yet. For that, we would have to do npm I to install the dependencies that our backend needs. So here we have, and if I'm gonna do ls, maybe -la to display it better, we see that we have this node modules directory with our packages. And what we can do from here is everything that we were able to do from our local machine. For example, we can do npm run dev to run a development build, and we see that it's watching, it's starting, but I think what we are interested in is actually npm start. npm start, what we'll do is we set it in the previous step. It will first build our source, and then we'll serve the index.js from the build directory using Node. And we see that our server is ready at localhost 3000. Let's check how we can send request to this instance. For that, we would need to go to our AWS console here. Let me make it a bit larger. And under the instances, find your instance, open it by pressing on the instance ID. And on this page, there should be the host name type. This is IP, but what I'm interested in is in this public IP4 DNS. So if I copy this one and I paste it here, it says this site cannot be reached because we are running the server at port 3000. So we need to specify $3000 here. 3000. And we see loading indicator. That means that there is something behind this URL, but it's not able to load. And that's because of the security groups. That's because of a firewall. And Vladimir, this probably will answer your question about security. So by default, nobody would be able to access our EC2 instance. to manage who and how is able to access our EC2 instance. For that, we have security groups. So on the instance page here on AWS, if we scroll down a bit, we will see the security here. What we see is in the inbound rules is who is able to access and on what port. We see that currently only these 3 ports are open. The 22 is the SSH port that allows us to connect from our local machine through SSH to our server. The 80 port is the HTTP port, and the 443, this is the HTTPS port. The thing is that we have to add to these inbound rules one more rule, and to do that, we're gonna press on the security group. So here above, there is the security group, to open it up in a new page. And for the inbound rules, we can press on the edit inbound rules. And let's go ahead and add one more rule. We want to allow to the port 3000, we want to allow anywhere from IPv4. So that would add this IP here. So from anywhere, we want to allow to send requests to the port 3000. Let's save the rule. Let's go back to our URL that we were trying to reach, and let's refresh the page. What we see right now is hello world, and at this time, it's not our local server running, because if I look at the VS Code, I don't have anything running locally. This is actually coming from our EC2 instance that is running in the cloud. Here, that is running here at the server localhost 3000. So far we have successfully installed and set up Node.js on EC2 instance. We have cloned our repository, and we have run our Node.js server on our EC2 backend, EC2 server. Yeah. I can go back to the instances. I'm not sure if I need that, but later on we will. And also, like, this is the public IP DNS, but you can also take them directly the IP address. So if I'm gonna take this IP address and add the port 3000 at the end, it should theoretically also allow me to see that. Why it doesn't? I don't know, but I think it should. Maybe I need. It doesn't want, but yeah, that's. Go ahead and use the public IPv4 DNS. So at the moment, if I refresh this page, we are able to access and to send requests to our server running in the cloud. The thing is that if I close this terminal window that connected from the SSH, from my local machine through SSH to the cloud EC2 instance, if I close this one and try to refresh the page, why? It's still running? No, after a couple of refreshes, we see that this site cannot be reached. Why? Because by closing that SSH connection, it actually stopped the server because we started it through that terminal. So it closed the terminal, it closed the server as well. So that's not exactly what we want for a server. We want it to run always. And for that, we will use a process manager for Node.js that is specifically designed to run Node.js application in production. That process manager is called PM2, and you can look at search it on Google, PM2 here in the home. And we're gonna use this PM2 to run our Node.js server, and this will allow will help us run the server always. We will be able to disconnect, it will still be running, If it will crash, it will make sure to automatically restart it. So it's a very helpful tool to run Node.js in production. So for that, let's open a new terminal. And at this moment, we're in the terminal, we're still on our local machine. So make sure to SSH into our EC2 instance. And this is an important step because maybe, And when we see the EC2 user and the IP address of our instance, here we are already working inside our EC2 instance. So what we can do is, let's go ahead and first of all, but no, I don't need to cd anywhere. I am in the home EC2 user, and if I do ls, we have a Twitter backend here. So what we have to do is, we see even from the homepage of PM2, like it's really nice that they show how to install and configure and start a new project right from the homepage. So let's go ahead and do npm install pm2-g to install PM2 globally. Let's scroll down a bit and we see how we can start an application. So PM2 start, and we need to specify the path to that folder. So I'm gonna do clear, and here let's do PM2 start. And the path to that directory is Twitter backend, because I'm in the home directory. Then it's in the build, then it's index.js. Okay, so what do we see here? We see that our index file is running and is online. And now we have access to the terminal, basically at the same time, while in the background, our server is running. So what we can do here to check the status of our server, basically, first of all, let's refresh the page in our browser to make sure that our server is running. Yes, it's running. You don't have to do that, but I'm gonna show you if I close this terminal, the server will continue running, because now we are doing it with a process manager with PM2, and it is running in background. Let's go ahead and open a terminal again. And let's SSH in our instance again. And here, after you SSH in the instance, you want to see like, okay, what's the status of our server? For that, you can run PM2 status to check what processes PM2 is running. So we can see that at the moment it's running the index, and the status is online, everything is fine. And yeah, what else you would be interested here? Probably in the PM2 monitor. So if you do PM2 monitor, you would PM2 will open a monitoring window where you will be able to see the logs. This is very helpful if something is not working in production and you need to debug, you need to look at the logs. For example, yeah, like the hello world will probably not show any logs, but if I take this URL, or if I go here to the, yeah, let's basically take the URL of our server. And if I'm gonna send a request, where is it? Let me open VS Code. If from Founder client, I'm gonna send a login request. Is it login? Or yeah, if it's login, but instead of sending it to the local host, if I'm gonna send it to our server by using it IPv4 DNS, I need to delete this one from here, 3000 then off login. If I'm gonna send, we see a bad request because not everything is completely set up yet, but in our monitor window, we're gonna see, hey, Prisma token create, invocation error, and so on. So that means that here is a place where we can monitor our server. You can exit, you can go back to the PM monitor and monitor in real time your server. Very good question. When we make updates to the application, this means that we need to restart PM2, right? Yes, that's very true. So for example, I'm gonna simulate us doing a change. That's a very common example, and let's cover it here. For example, we want to work on a new feature. We open locally, we go, for example, to the source index, and here, instead of hello world, hello, I don't know, updated world. We make some changes. We test it locally, everything is working fine. For example, testing it locally, you do npm run dev. You would open the local host. Let's wait for a second. You'd open localhost, come on, in your browser, let's say localhost 3000, and in the localhost we see hello updated world. On the server, if I refresh the page, it's still hello world. So these changes should somehow go from our local machine to our server. To do that, I'm gonna close the local server here, and let's commit everything. So I'm gonna add these changes, and I'm gonna commit a new commit with updates. Let's push these changes to our Git repository, origin main. Git push origin main, perfect. And at this moment, our changes are on our Git repository. So in Git repository, we see that the last commit was modifying the source with message updates. That's exactly what we did. So from our local machine, at the moment we push the changes to the GitHub. Now from our server, we need to pull the changes from GitHub. We need to pull the updates. So what we're gonna do is we're gonna first connect through SSH to our server. You already know how to do that. You're gonna open the directory of our application, cd Twitter backend, and here let's go ahead and do git pull. We see that by git pulling, we have some changes to the source index. That means that the files have been pulled from the server. If we're gonna look at if we're gonna refresh this page, it's still not showing the update. Because first of all, we need to build the new changes. So go ahead and run npm build. This is a very important step because without this, restarting PM2 will not take into consideration the new changes. We need to first build. For that, npm run build, run build. To take our source, build it, and put it into the build directory. After that, if we refresh, it's still not there because PM2 is running on the previous state of our backend. So what we have to do is we have to restart PM2 with the new changes that we have created. To do that, what we can do is do, for example, PM2, first of all, ls, or status or ls, these are both will show the instances that are running. And from here, you can either do PM2 restart all, this will restart all the processes, or you can do PM2 restart and provide the name of a process, in this case, restart index. So applying action restart process, it restarted. And now if I'm gonna refresh in the browser, we finally see hello updated world. So to recap how you go from a change to a deployed in production change, first of all, you're gonna do all the changes where you're gonna build a new feature locally on your machine. You're gonna test and make sure that it is working as you would expect. The next step is to commit and push all the changes to your Git repository. And after that, we have to move from Git repository to our server. For that, go ahead and connect using SSH to your EC2 instance. There, pull the changes in from your repository. Make sure to rebuild your application in order to make sure that your build directory contains the latest changes. And lastly, restart your server using PM2 by running PM2 restart all or PM2 restart and the name of a process. And after that, all the changes from your local machine will be available in your production environment. Can this pull build start be automated? Yes, definitely it can be. For that, you'd have to set up some CI/CD processes. and every time you do a push on the Git repository, the CI/CD process to automatically build, maybe even test your project, and finally deploy and finally pull it and push these changes to your server. So that's possible, but it takes a bit more time and it's a bit more advanced. It's out of scope for this tutorial. At this moment, we saw how we can do this manually. Guys, we are 1 hour in. What we have done so far, it's actually, it's actually quite a lot. So we are at halfway through this tutorial, and so far we have prepared our Node.js backend to be deployed to production. Then we created an EC2 instance for our server that is going to be run in the cloud. And we connected, we set it up, and we run our application on that server. The next step is going to be to create a PostgreSQL database using AWS RDS server. This is also a managed database server by AWS, and then connect from our backend to the Postgres database there. So yeah, that's also some very important steps in order to build a distributed system where you have separate servers for your API and for your database, because the alternative would be to, on the same server, to initialize or to continue using SQLite. Let's speak a little bit about this example. At the moment, our Prisma, our backend, is using SQLite. And if we look at the environment, actually I forgot to set up the environment. So yeah, I'm gonna do that in a moment. But yeah, our Prisma is using the SQLite provider, which means that this is an integrated database, which means that this database is basically a file on the same system that our API is running. What does that mean? Well, first of all, it means that only this server will be able to use that data. Later on, if you would want to scale horizontally by running multiple servers in parallel, all of them, they basically will have their own database. And that's not what you want. You want all the data to be in one central database. And then when you run multiple servers, to connect to the same database in order for everyone to use the same data. Another problem with this approach is if we want to use a bigger instance type, for example, if this instance type is already not handling all the requests and you want to move to a new one, you'd have to remove this one and create a new instance type. But by doing that, you would remove the database file. So you'd make sure you would have to migrate that file to the new server, to the new instance. So as you can see, keeping close together your web server with the database where the database is located is quite a bad, how's it called? It's not recommended because it has a lot of drawbacks. The alternative is to use a separate server where you're going to run the database that is only going to be responsible for the database, and then from your web server to simply connect to that database server. And in this case, they are decoupled, and what you can do is, if your web servers need to be scaled, you can basically remove, you can add new ones, you can scale horizontally by running multiple instances that are connected to the same database instance, and everything is going to be much more easier to be updated, to grow in size, and to later scale. Now, to run that database, the Postgres SQL database, on a separate server, one option would be to go ahead and create another EC2 instance and to basically install Postgres, set it up, make sure to secure it properly and run it, and then handle all the scalability and so on. That's possible, but that's a bit tedious and requires a lot of management work for us in order to manage the server and the security of the database. Instead of that, what we can do is to use a specific service from AWS called RDS, which stands for Relationship Database Service. And this service gives us the possibility to run SQL databases in the cloud on managed servers. Managed servers here means that we do not, like AWS is managing the server that is using behind the scenes for this database, and we as developers are only responsible for the database itself. We can simply connect there, and everything else is taken care by AWS. For example, scaling it up, making different replicas, or creating snapshots and doing backups. So it's a way easier way to create and manage relationship database rather than doing it yourself on an EC2 instance. Like behind the scenes, RDS is still using EC2 instance. The only thing is that it's not your responsibility to manage those EC2 instances. So in this step, let's go ahead and create and set up an Amazon RDS service to create a database, a PostgreSQL database that we're going to use for this project. So go ahead and search for RDS in the search. Go ahead and RDS is still on free tier. Yes, we're going to use RDS on free tier, but pay attention at the option that I'm going to select next, because that's going to be important. Oh, I see that we have new viewers. So welcome on the channel. If you're new here, make sure to subscribe, because we have a lot of valuable tutorials on full stack development. We cover a lot of mobile development, but we also cover like backend. Now we're going into infrastructure. So it's really fun way to learn by building exciting projects. And if you subscribe, basically that means that you are part of the 1%. And what do I mean by that? Let me actually show you if I can find it. I don't know where it is. No, but I'm gonna show you. That's very, very important for you to know. Is it on desktop? I want to prove my point, guys. Okay, here it is. So look at this graph. In the last 28 days, 98.5% of people watching these tutorials are not subscribed to the channel. And if you are part of a 1%, make sure to write down in the comments 1% club. We are here, and I really appreciate your support. It's just a number of the subscribers, but it really helps us reach more developers, help more people, work with better companies, and provide more and better tutorials for you guys. So we're doing this full time. We have a huge team, not a huge, we have a small but a very powerful team. And we would appreciate your support in helping us reach more developers and help more people. So make sure to subscribe, turn on the notification bell. We're going live every single Friday with fire content. Thank you. Now, 1% Club, Youssef. I think you are part of a 1% Club for a very long time. I remember you. Thank you. All right, so let me see if there are any questions so far. Unknown, you're asking about React Native, Django, PostgreSQL. Will I face any advantages or disadvantages? Basically, anything that you're learning is an advantage. So it doesn't matter what you're learning, it's good that you're learning. Go ahead, continue on your path, follow your passion, and everything is going to be okay. Where is Vladimir? Vladimir, where are you? Okay, so where are we at? So as I said, go ahead, search for RDS. Let's open RDS dashboard. And from here, let's go ahead and press on the create database. For the create database, let's go with a standard flow where we will be able to choose some of the preferences. For the engine options, go ahead and select PostgreSQL. I'm struggling pronouncing it. Is it PostgreSQL or PostgreSQL? I don't know. I'll say PostgreSQL or SQL. I don't know, that's even harder. But I think you get the point, and that's not the most important part about this tutorial. For the engine version, leave it for as the default. And the next step is the template. The template provides some predefined configuration for different scenarios. For example, if you're running for production, that will create, for example, a multi-availability zone database cluster, which means that if your database is going to be spread in different availability zones, and if one data center, I know, catches on fire, that means that your database is still going to be online. And this is recommended for production if you really don't want to miss on like to be offline. Yeah, let's say it like this. You can do a development test, or what I would use and what I would recommend you to use for this tutorial is the free tier template. The free tier is specifically for to develop new application or to gain hands-on experience with Amazon RDS. And for this tutorial, that's going to be what we need. And this will ensure that you are staying under the free tier and you're not going to get charged. So let's go ahead. Now that we chose free tier, the availability and durability was selected automatically for us as a single database instance, which means that it runs one single database instance. It doesn't have multiple backups in order to keep up, like if something happens to the main one, but it's okay for development because not at the same time, things like an availability zone to go offline is very, very rare. So most probably you're not gonna encounter any issues. Let's move on to the settings. For the name of our database instance, let's go ahead and say Twitter, but make sure to remember this identifier. In a moment, I'm gonna say like, remember that name, we're gonna need it. So let's go ahead and actually put it in the notes because I'm pretty sure all of us will going to forget it, even including me. Oh my God. Oh my God. Come on. So DB instance, that's going to be Twitter. Credential settings. This is very important again, and it will allow us to connect to our database. Let's leave the username as this Postgres, but at the same time, I'm going to take notes and I recommend you do the same. So username Postgres, come on, Postgres. And for the password, go ahead and select one easy one and make sure to also, not easy one, like select a good password, but make sure to write it down because again, we're gonna need this in a moment when we're gonna connect to this database. I'm gonna use a super easy one because at the end I'm gonna delete this database, and that's gonna be fine. But for you, you can either auto-generate or use a secure password here. Moving on to the next step, instance configuration. This will allow us to select what EC2 instance should our database run on. So again, I explained at the beginning that yes, we do not manage those EC2 instances. They're managed by AWS, but we have a possibility to choose which one. So I'm going to leave that T3 micro that is also under the free tier. And as we can see, like the others that are not under free tier are grayed out because we only want free tier. Let's move on. For the storage, here is where we can specify how much storage should our database instance have. 20 gigabytes is more than enough for a lot of records, so I'm gonna leave it like this. But also it has auto scaling. So if your database will run out of space, it will automatically scale in storage until it reaches this maximum storage threshold. Okay, moving on to the connectivity. Connectivity is how do we want to be able to connect to this database. So connecting to this database is going to happen from our web server that we created in the previous step. So let's select here connect to an EC2 compute resource. And from here, we can select the one that we created in the previous step. In my case, that's Twitter API. This will add some configuration to allow our web server to connect to our database. Let's scroll down until let's leave automatic setup for the subnet group. Public access here, we are not able to select public access because that would require an additional AWS server, because from the security standpoint, that's perfect for us because nobody from outside the virtual private cloud, from the network created in our cloud in AWS, nobody outside of that network would be able to connect to our database. And that's perfect for security of a database. That's exactly what you need. You want only your server to be able to connect there. However, this will imply some limitations. For example, we will not be able to connect from our local machine there. Later on, maybe I'm going to explain you a bit how we can allow secure connection from local machine to this RDS. But for now, it's fine like that. We do not want public access. We only want our web server to access the data, to access the database. And everyone else will only have access to the web server. VPC security group. We can let's select create a new VPC security group. And this one will be Twitter database security group. This here is the availability zone where it will run. It will run in the US East 1 and the availability zone B. And for the database authentication, let's leave a password authentication that will allow us to use username and password to connect to this database. But yeah, this is one layer of security. Another layer of security I just discussed in the previous step, where only servers from our VPC from our cloud will be able to access it. So that's even a better security. And yeah, and moving on to the next step, I'm going to leave everything as default for the monitoring. And we are done. Here we can see some more information about the costs. So the RDS free tier is available for 12 months after you created an account. and it offers 750 hours of RDS in a single availability zone. Yes, that's what we created with database T3 micro. That's what we use. 20 gigabytes of general purpose SSD. That's the storage that we used. And also 20 gigabytes of automated backup storage, but we didn't set any backups yet. So with this information, it says that, yeah, we are under free tier and we're not going to get charged in the first 12 months of using this RDS, of the creation of our account, sorry. So let's press create database. And that will start creating and setting up our database. I'm gonna close this one. Oh, the name is Tweete, not Twitter. Okay. Tweete. Okay, so the status of our database is still in creating, and it's gonna take like a couple of minutes until all the resources are set up and our database is ready to receive connections. But that's good because we have a couple of steps to change from our application code. So let's minimize this, and we're gonna get to that in a moment. And let's open our VS Code. Let's open our VS Code with our backend. And here, what we want to do is let's go ahead and open Prisma, schema.prisma. At the top, we see that for the database, for the provider, at the moment we are using SQLite. As I explained previously, this is an embedded SQL database that is running locally. And what we want to do now is we will have to switch from SQLite to PostgreSQL. Come on. To do that, there are some documentations. For example, this one. Where is it? For example, this documentation, which is under Prisma documentation for the database connectors. Let's see how we can connect to the PostgreSQL database. To do that, what we have to do is to change the provider to PostgreSQL. So let's copy this name. Let me zoom in a bit. Let's copy this name and change it in our schema.prisma here. Now the URL should also be changed, but this URL is coming from the environment variables as database URL. If we're looking at the environment variables at the moment, the database URL here is specifying the file. What we need is to provide a connection string that specifies how we should connect to our Postgres database. If we look at the URL, here is more information and details about how this URL is created. So we see here base URL and path. It's created out of this property. So let me copy this URL and paste in the database URL here. Let's explain all the steps. So first of all is the name PostgreSQL, then the double dots and // This is specifying, okay, I forgot the name. The database that we want to connect to. The next one, this is a variable and we need to replace the user with the actual user that we created when we set up our RDS database in the previous step. So here is where your notes will come in handy. So open up your notes, and for the user, I told you to leave Postgres, the name of a username, Postgres. So if you left it Postgres, that's gonna be here, Postgres. For the password, again, we need to replace it and make sure you have these double dots between the username and the password. And my password is going to be this one. 123, 123, 123. For you, take it from your notes and put your password here. The host, where do we get the host? The host part, we can go to the dashboard of our databases, RDS. Let's open the database that we created, and under the connectivity and security, there is this endpoint, and this endpoint is the host. So let's copy it from here and replace it in the host part. Next one, port. If we go back under that endpoint, we see the port 5432. For you, it should be the same, 5432. Lastly, the name of a database. The name of a database, in my case, is Tweete. In your case, take it from the notes or look at how the database is called here under the database identifiers. So in my case, it's Tweete. So that's what we have at the end. And with this, we have the full connection string that will allow us to connect to our Postgres instance. Okay, the next problem is that there is a limitation whenever we change the provider from, for example, SQLite to Postgres SQL. The limitation is that at the moment, if we were working with SQLite, all the migrations were created for that provider. Now that we change to a different provider, those migrations might not be compatible. So if we would try to migrate now and change this, to have these changes, we're gonna receive an error. The solution for this, and actually there is a documentation here to Prisma migrate and limitations and known issues. And what I'm talking about is you cannot automatically switch database providers. What we should do is we manually change the provider, we change the URL, and we basically remove all the migrations and then create a new migration that will specify how do we take an empty database, migrate it to the current state of a database. So to recap, what we have to do is in our project, go to Prisma, under the migrations, go ahead and maybe instead of removing it completely, maybe you can move it to another place, because later if something is not working, you can bring them back here. In my case, I'm gonna remove all of them. So delete all migrations. Now the migration is an empty folder. And to create a migration, usually what we have to do is to run npm run, not npm, but npx prisma migrate dev, and then name, we can call it, like Postgres init. Trying to run this migration to basically create the changes in our new database will fail because it says that it cannot reach the database that we specified. Why is that? That is because of a previous reason I was talking about. Our database does not allow public access, does not allow access over the internet, over the public internet. So at the moment, there is no way from our local machine, which is here, to connect to our RDS database. So what we have to do is, let's go ahead and simply add all the changes, git commit -m, switch to Postgres provider, and let's do push origin main. And now let's go ahead and pull all the changes in our backend, on our server, and from there we're going to be able to run the migration, because from our server we are allowed to connect to our database. That's security. So I have, I'm gonna close this one. I have the terminal here connected to my server. Again, if you don't have it, so I'm gonna maybe close it. Again, just open a terminal. And let's do SSH into our server, EC2. And from our web server here, let's go ahead and CD into the Twitter backend. Here we have our changes, our project, and let's go ahead and pull all the changes from our Git repository to get the updates. So git pull, and that's it. We see that, yeah, like we deleted a lot of migrations and we updated the schema. That's exactly what we wanted to do. The next step would be to, if we look at the maybe LSLA, we see that we have a .env example, but we do not have a .env file because the .env file is not tracked in our Git repository, again for security. So what we have to do is let's either create that .env or using the example, do a copy using cp .env example into the .env. And this will copy the file env example to a new one called .env. Now if I do lsla, we see the .env file. Okay, now what we have to do is we have to edit that .env file to include the URL of our database that should use there. So how do we do that? Oh, we are going to use Vim. If you haven't worked with Vim, I'm sorry for the next couple of minutes. You're probably gonna have to Google like how to close Vim, but at this moment, like that's probably I would say the only word, like the best way we can edit some files on our server. We cannot open it in Visual Studio Code because it's not on our local machine. So what we have to do is run vim and .env. This will open our env file in a very primitive editor. So let's move down to the database URL. Let's move our cursor inside this string. Let's go to our Visual Studio Code to get that connection string. So from .env, where we created this connection string, let's copy it from here, only what's inside the string. Now, let's go back here, and what should we do? We should first press on the I to switch to the insert mode, so press I. At the bottom you will see insert, then do Ctrl V or Command V on Mac. Then let's also actually add a JWT secret. I don't know, for now it can be secret. And now we need to save and close Vim. That's the most challenging part of deploying something on the server and working with servers. Closing and saving Vim. I'm gonna say what you have to press step by step. The first one is escape. Press escape. Now you do not see the, is it escape? I'm lost. Yes. Press escape. You should not see the insert anymore. Now you need to type double dots for the command that you want to run, then W for writing, and then Q for quitting. So double dots, W, Q. Then press enter, and that should close Vim. And if we do cat to show what's inside .env, now we should see the updates are persisted. If you manage to close it, if you manage to edit it, good job. Otherwise, go ahead. Yeah, like there are some comments in the live chat as well for the commands that you have to do. But yeah, I hope you managed to do that. Now what we have to do is Always, of course, we have to build, even though now maybe we don't have to, but let's go ahead and do npm build to build our backend, npm run build. Why do I forget npm run build? And now what we have to do is we have to restart our server. Or no, actually before restarting our server, as I said, our goal was to run the migrations for our Prisma in order to create and set up the database tables that we have in our application. So for that, what we have to do is using npx Prisma migrate dev, and then we can provide also the name, or let's not provide the name because I forgot the syntax. So npx Prisma migrate dev, press enter. That loaded the environment variable from there. Prisma schema loaded, database is PostgreSQL. It was created, and now it asks us for a name for the migration. Init Postgres. Applying migrations, and we see that it successfully created and synchronized our Prisma schema to our PostgreSQL database that is running in our RDS. So I'm really surprised that everything worked from the first time, and I really hope that for you it worked as well, because if it didn't, most probably the problem that you are encountering is misconfiguration inside if I do vim.env. So the most probably this connection string is incorrect. So double check every single character here. Make sure that the username and the password matches. Make sure that you have everything here. And if that's the case, like everything else should connect correctly. Because yeah, like if you follow the configuration step by step that I showed you. Okay, and lastly, we can go ahead and restart our server, pm2 restart all. And this will restart our server that is running to switch and be using our new database connection that is connected to our PostgreSQL. So now this is localhost, I don't need it anymore. This is our EC2. And if you lost the URL, to do that, navigate to the EC2 dashboard, go to the instances, select the instance that you're looking for, and take the public IP DNS here, open it in a new tab, and make sure to add the port 3000 here. Hello, updated world. So that means that we successfully connected there. Now let's go ahead and try to send a request here to make sure that everything is working with a new database. We can either do that from, let's do the first one from a Thunder client through your HTTP client of choice. What we want to do is to send a post request to make sure that would interact with the database, to make sure that everything is working perfectly there. And also what I would like to do on our server is I want to run pm2 monit to monitor our API. So from our Thunder client, let's open the /auth login that is responsible for logging in. Make sure that you are not sending the request to localhost, but to your EC2 instance, here the URL. And previous time it was a bad request, couldn't start the authentication process. Now if I'm gonna send, I hope that it will work. Yes, we see, okay. If I will look on my email, I will not see the email with the password, with a one-time password that it's supposed to send. And you would think that, oh, something is not working. To debug it, you would go and look at the monitor logs to see what's going on. So what we see is that, yeah, it created in the database the token, and it was trying to send it to my email, but the problem is that error sending email something. What that means is that if you remember, in our source services email service, here we are using the SES client to send emails. The SES client should know how to connect, should have credentials to connect to our SES, to AWS SES in our account. In the previous episode, I showed you like locally that you can configure that using the AWS key ID and AWS key secret here in the environment variables. On the backend, you could also do that, but in production, a more secure way to give access to your API to different resources in the cloud would be by assigning a YAM role to our EC2 instance. I really hope that I don't confuse you too much, but what I mean by that is instead of manually writing the key and password and the secret key, which can be, if someone has access to them, they would be able to access your AWS account. You don't want that. In that case, a better solution would be from the EC2 dashboard. Let's open our Twitter API instance. And if I look at the security, is it security? Yes, at the security, there is this YAM role. YAM stands for Identity and Access Management and specifies who is allowed to access what in our AWS account. At the moment, it doesn't have, our server doesn't have any YAM role. What we can do is at the top under the actions, let's go ahead under the security and press on the modify YAM role. Let's go ahead and instead of choosing one, I'm going to create a new YAM role specifically for our database. And by having a specific YAM role for a specific server, we're going to be able to give to that server access only to services and resources that it has to have access, instead of giving it access to everything in our account. Again, this is a much better and much more secure way of managing permissions on AWS. So for the roles, let's create a new role. So press on the create role. And here, we want the AWS service. Here is an example. We want to allow AWS service like EC2 or others to perform actions in this account. That's exactly what we want. We want to allow an EC2 instance to perform some actions like sending an email using SES. Let's move down, common use cases. I'm going to select EC2. Let's press next. Here for the permission policies, we can either create a very specific policy for this one that will specify to what services it has access, or we can use a predefined one. For example, I will search SES, and here there is a permission that gives SES full access. So I'm going to select the SES full access, and I'm going to press next at the bottom. For the role name, let's do Twitter API role. Allow EC2 instances to call AWS services on our behalf. That's okay. And let's press create role. The role was created. What we have to do is to go back to our modifier role to the previous page from where we are coming, to the modify YAM role of our instance. And here, let's press choose YAM role. I think we will have to refresh it and choose YAM role, Twitter API role, the new role that we created. Let's press update YAM role. And now if I'm going to look at this instance ID, we see that under the security, it has this Twitter API role. And later, if you need to give more access to this server, for example, now it needs access to SES. If later it will need access to something else, you can come here and give and update that role to include other permissions as well. Okay, let's try to, without, you don't have to restart anything. It will take effect automatically. What we can do is to send a new login request. So let's send this one. We get status code 200, but we need to double check the logs. And the logs, I think sending email region is undefined, right? So if I will check, it's still not gonna work. Yes, it's not gonna work because I mean, we fixed that problem with permissions. The only step that we didn't fix is specifying in what region do we want to access SES client. So here we can provide region, and it's either we will hard code it here or it's better to take it from the environment variables. But I think it will automatically be placed here if it is available in the environment variables. But that should be tested. So let's, without changing anything in our code, let's go to our server. Let's close PM2 monitor. And inside our project directory, if I do clear pfd, we are inside our Twitter backend. Let's go ahead and open .env file with vim. So vim.env. And here, let's press I to insert, go to a place below the JWT secret, and let's write AWS region equal to the region that our application is deployed to. To see that, we can open AWS console, and here at the top there is the region. In my case, it's North Virginia, but the code of North Virginia is US East 1. So double check what region is currently selected for you and take the name of that region from this menu. In my case, I'm gonna take US East 1, and in my Vim here for AWS region, I'm gonna say US East 1. Again, escape, double dots, WQ, and that will save and quit Vim. And what we have to do is to restart our server by doing PM2 restart all. It restarted, it used the new environment variables, and we can do PM2 monit to monitor. And let's go ahead and try to send the login request again. Send. And I expected, yes, it automatically took it from the environment without us having to specify it in our code. If the region is available in the environment, AWS will know how to take it from there. So we don't see any errors anymore. And if I look on my email address, I actually receive a one-time password, and it matches this one that it says here. So what I can do right now is I can copy this one, and from Thunder client, I can authenticate basically to continue using it. But I'm not going to continue this way because so far I'm pretty sure that everything is working correctly. We saw that our backend successfully creates data in our database from RDS. It successfully sends email. So everything is working in production. What we can do right now to test everything in an easier way is we can run our actual Twitter application. Let's see here, npm start, and make sure to connect from this application to our, instead of to local host, to communicate with our public API that was deployed to EC2. So we are very close to finishing up. I want to maybe show you also how we can clean up everything in AWS. Maybe show how to set up PostgreSQL locally. And then I'm gonna have to run to prepare for the next talk that I'm gonna have today. Do you have any questions so far, guys? Do you enjoy it? So what I want to do here while I'm waiting for the application to run is let's go ahead and check where in the library config API URL. At the moment it's using localhost. Instead of localhost, let's use our DNS of our instance, for example, Twitter API. I'm going to copy this DNS and I'm going to replace it here, but I'm going to leave that port 3000 because it's still working on port 3000. And I think it misses the HTTP. Yeah, something like that. So at this moment, it is supposed, yeah, it says not authorized, please sign in. Let's refresh. Basically, it says that it has a token that expired, but it doesn't redirect us to the login page. So what can I do? You would have to, like, if you receive not authorized, please sign in. What you'd have to do is to remove a token from your async storage and redirect to the login page. In my case, I don't have time for that at the moment, so I'm gonna simply uninstall Expo and run it again, and that will run fresh. Oh, it still has that one. So I'm gonna have to do something for the code. Where? For example, for where do I want to do that in an easy way? Load of token. Update of token. Let's create a new function here. Remove of token. Wait. Does it have a remove? Delete item async. Set of token to null. Yep. And let's export this remove of token from the context provider. And then from our API, for example, tweets, on this one, not authorized, please sign in. I think I can simply say remove of token that we have to import. So now, but it only works for one request. Like it's not the best solution what I did right now, but basically like if I receive a not authorized error, like I'm going to simply remove authentication token, and that will automatically redirect the user to the sign-in page. And now what we want to do is here, let's go ahead and create a new account with the email Vadim notjust.dev. We should receive an email on our email. Yes, we did. And I'm going to use this one-time password that I received, 232 12814. Confirm. And we are in the feed. In the feed there is nothing because it's an empty database yet, but we can create a new one. Hello there. Tweet. And we see the hello there tweet. And that's now if I'm going to refresh the application, the data is still there and it works as expected. Okay, so that means that everything is connected successfully with our RDS. Everything is running in the cloud, available for anyone to access it. Here in the monitoring, you can maybe also look at what's happening here. Database connections. We see that there is currently one database connection. Our backend has connected to it. And perfect. Yeah. Everything is working fine. So, guys, so far, yes, we have done a lot of things. We have deployed our Node.js API to AWS, to an EC2 instance. We have connected to that, we set it up. Then we created even a database layer using AWS RDS that runs our Postgres SQL database. And from our web API, we connected to that RDS table to have like separate servers for our web layer, for our API layer, and for our data layer. I hope you enjoyed this one. Lastly, I want to show you how we can clean up the things that we have created so far in order for you not to be afraid that you're going to get charged later. As I said before, these are not serverless services, which means that as long as they are running, they will basically, you will be charged. In the first year, you are under the free tier, so you don't have to worry. But if you're going to leave this for 5 years ahead, like you're going to start getting charged very small amount, but still like it's going to charge your account. So if you're done with this tutorial, it's a good idea to go ahead and clear everything. So I'm going to start with the Amazon RDS, and I feel so bad deleting everything after working for 2 hours and setting everything up, but let's go ahead and do that. So let's select the first one is our database. So from RDS, let's go ahead into the database instances. And for the Twitter, let's do actions and what? Delete. Are you sure you want to delete the database? Create a final snapshot. That's if you want to save the data that was inside the database. I don't want to do that. Retain automated backups. I don't want to retain that. It was only for experimenting and learning. And I acknowledge that deletion will no longer be available. Perfect. So let's press that and delete. Delete me. If you have some important information there, you can of course create a final snapshot, and that will include with that, like later on you'll be able to create a new database from that snapshot and get access to the previous data that you had in the database. For now, I'm going to press delete. And we see that the status is deleting. And I can do this one as well as we are here. Delete me. Okay, that was the RDS. Back to our web API, to the EC2 dashboard. Let's go ahead at the instances. Let's select the one that we want to delete, and from the actions, let's go to the instance settings. No, to the instance state here, not action by instance state. So here the first thing is, like we can stop the instance. That will stop running the instance, but you will still be charged for that instance. So what we want to do is to actually terminate the instance. The default action is for the root EBS volume to be deleted when instance is terminated. Storage on any local drivers will be lost. So the storage on local drivers will be lost. Are you sure you want to terminate these actions? Yes, terminate. And I'm gonna do that for this one as well. Terminate. In case, like that's what it's saying. Like when we stop the instance, it stopped the EC2 instance, but the storage that is used by that instance is not deleted. So when terminating, it actually also deletes the storage as well. So terminating. Now let's make sure that we don't have anything else here. For example, the volumes. This, I think they will be automatically deleted once our instance is deleted. So let's wait for a bit. We see it's terminated. Can we also get rid of it? And if I look at the volumes, I'm not sure if these were used by that instances. I think no. We can also delete the security groups that were created during this process, but security groups will not charge you anything. So even if you forget about that, that's okay. The most important part is to stop and terminate the instances from your dashboard. So now if I'm going to refresh this one, I should have instances running 0, and that's the most important part. The same thing with database. Database is something that is going to charge you, so make sure to delete them as well. It's deleting, so this is going to take a bit more time. One thing that I want to say is that now that we switch to RDS, the problem will be that to work locally, it's going to be a bit challenging, because at the moment, working locally on your API is not going to work, because what we have here is basically we're not going to be able to connect to our Postgres database URL, to our production database. So what you would have to do is you'd have to create a new development database, and I would recommend creating it locally on your machine, running a Postgres database locally that will serve as your local and development database, where you can do tests and then deploy everything to production. And after you create and set up a Postgres SQL database, make sure to change this database URL connection on your local, in your local machine, on your local device, to connect to that development database. And to learn more about how you can set it up, there is a nice tutorial on the Prisma guide, where it shows how we can set up Postgres SQL on Windows. It also has setting up on macOS down below. On macOS, so simply follow this guide to install Postgres SQL locally in order to be able to continue developing your API locally and connecting to a development database instead of having to connect to a production one. You'll not even be able to connect to the production one. So you would have to connect to a different development Postgres instance. But yeah, that was everything that I wanted to show you today, guys. It was really a fun tutorial. I hope you enjoyed this one. If you enjoyed, make sure to subscribe to the channel. Let me know in the comments what other tutorials and what other things you would like us to cover, because we have a lot of plans. We have a lot of ideas. So for that, make sure to subscribe to the channel, turn on the notification bell, and write down in the comments that you are part of a 1% club, to the people who subscribe to the channel and are watching these tutorials. And yes, you are only 1% if you are subscribed. So that's our private club here. I'm going to have to go to prepare for the talk that I have today later at a conference here on the island, the JavaScript conference. Super excited about that, and see you next Friday with a different tutorial. I see 1% club here. Awesome. Okay, guys, take care, stay hydrated, write clean code, and I'm out. Bye-bye.